small signal AC analysis. So as I told you yesterday, if you have a transistor, say this is your ammeter, this is the collector, and this is the base. And if IB current is flowing here, IB, okay, IC current is coming here, and IE current is coming here. So in a small signal analysis, we have to write a equivalent, draw equivalent model for your transistor. Okay, and now what is the equivalent model? Equivalent model is equal to, now I told you this is diode, this junction NPN. Okay, so whenever you have a diode, this diode for small amplitudes, if it is a DC bias, and you apply a small signal, then I can replace, once I know the DC bias, then they can do AC analysis, okay, and I can replace this diode by a resistor. I can replace this diode by a resistor called RE, and the RE value is 26 at room temperature, 26 millivolt upon how much current is flowing through the diode. Because of DC source, if ID current is flowing, okay, then I can write the AC signal is your ID. Okay, so whenever two sources are there, first you will solve, first you will do DC, first you will do the DC part. DC part means DC part means what is DC? This is the AC part. This is AC analysis. And before you doing AC analysis, what you supposed to do? You supposed to do DC analysis. That is, this is the battery, this is the V input. You first do BC, turn off this one and do analysis with this one, then turn off this one and do analysis with only this one. So this is your AC analysis, this is your DC analysis. You have to first find ID. How much ID is flowing? Once you know the ID, you can do AC analysis and you can replace this by register. So same thing I have done yesterday, that this part of the this junction, PN junction will, for AC analysis, first we do DC analysis like what we are doing earlier. And when comes to AC analysis, I will just replace this transistor by a equivalent circuit. That means by a resistor. So now this will be my base terminal, IV current is flowing, and I'll say this is my resistor. I can say this is my resistor. This is coming resistor. This will I will replace by a resistor RE. And now this is, if this is the grounded, I can make it grounded. Okay. Similarly, now what about this is the input part? Because input characteristics is like this only. Input characteristics, diode is just a resistor, a fixed voltage resistor. Okay. This is my IC versus ID versus VD. So I'm replacing, for input part, I'm replacing by a resistor called RE. Now what about the output? Output IC current also coming, fixed current IC coming, and that is coming from here to here. And output characteristics, you know, output characteristics have a very high resistance. It shows that output terminals have very high resistance, ICs versus VCE. So output terminal I have to replace by a say this, just make it for simple. I will make it like this for your understanding. This is your RE, which this is common between input and output. So I will put it common like this. I'll put this RE, and I say here a current is coming beta IC. Okay, IC is equal to beta IB. This current is coming here. Here. This is a diamond shape fixed current source. Okay, So this is a voltage dependent. This is a dependent source, dependent current source. Dependent sources, whenever there are independent sources, we draw like this or like this. Whenever there is a voltage dependent or current dependent sources are there, we draw by a diamond shape signal. Okay. Now this current is coming IC. So I say this current IC is coming here. Beta IB current is coming here. Now this IB plus IC combining together, here IE is flowing. Okay. And I know the IE is nothing. IE is beta plus 1 IB. And this is almost equal to beta IB. And this is grounded. So now I want to replace this part and this part. Output here we have only IC and here is coming IB. So this circuit I can draw like this. I can say RE, this is RE, and this is grounded, and only IB is flowing, and this part only IC flowing. So I can say a current source. This is IC beta IB equal to IC is flowing here. So the idea is what? Whenever this part of the transistor comes, you have to replace by this circuit. Okay, because now this is grounded, so you can directly do ground. Now once I replace by RE, the actual current is here IE. Okay, but here current is IB. So I have to make this current IE. So IE is beta IB. So I instead of multiplying this current here, I'm multiplying beta with this one. Now the voltage drop because of this IB is here beta IB. So either you put IB current is, you say current is IB, resistance is beta RE. Either you say current is IB, current is here IE, resistance is RE. Or I say current is IB and resistance is beta RE. So input resistance will be replaced. This resistance of diode will be replaced by beta RE, and this is the current circuit. So this is called equivalent model. This is called equivalent model. Okay. So just you have to just remember, whenever transistor is like this drawing, you have to replace by equivalent. That means input part you have to replace by a resistor, output part with a current source, and if you want include this high resistance part, infinite resistance part, you can put a resistance R0. And if this R0 is infinite, again this will be open. So this is the equivalent circuit, equivalent model, small signal equivalent model. Okay, small signal equivalent model for transistor, and this is called your RE model because you're replacing transistor by a resistor. Deepak, you have any question?
No, sir, got it.
Okay, so बस इतना याद करना है आपको. You just remember this will be replaced by this part. That's it, nothing else. And now the remaining thing is the same. Now let us do the problem. Okay, so I'm erasing this one now. So एक क्वेश्चन करेंगे तो पूरा क्लियर हो जाएगा, बहुत आसान है, वेरी सिंपल. So what is the idea? So before you should, if you want to do the RE model, number one is you have to do DC analysis. Yes, as I told, what are the steps? You can remind one time more. DC analysis, first is DC analysis. Okay, and find IE value, find IE. Okay, once your DC analysis, now you DC analysis, capacitor will be open. Okay, capacitor are open. Okay, second AC analysis. AC analysis, what will happen? You have to do number one, turned off all the power supplies, turned off all DC power supplies. Once after doing this one, draw a simplified circuit, draw a simplified circuit. Then once draw a simplified circuit, then replace transistor by RE model, and the last is, okay, calculate following quantities. Calculate following, let me AC analysis, following quantities कौन कौन सी हैं? नंबर 1 इनपुट रेजिस्टेंस RI, input resistance. Number 2 output resistance. Number 3 voltage gain. जरूरी नहीं कि सब कैलकुलेट करना है, जो भी एग्जाम में बोलेगा वो कैलकुलेट करना है. So and the last is your fourth is your current gain, I naught. Voltage gain will be written by A naught, AV. Voltage gain, A is gain, and AC current gain. Output voltage V naught, current gain. Okay. So now, for example, let us understand with some example. Can I erase this one?
Sir, wait for a while. Sir, done.
So first we'll take the simplest biasing, and for this one we will do the calculations. Okay. So you have a transistor, fixed bias, RC, RB, and here you have a ground. Here you have a capacitor. Here you have a capacitor. Here you want to apply input. Here you want to apply output. Input current is coming here. Output current is coming here, and V naught you're measuring here. V naught V input you're applying here, and V naught you're measuring here. So you can say that is the 2 are input terminals and 2 are output terminal. So this is a output terminal. This is a I coming input terminal. You are applying a V input and you are measuring a V output, and this is your amplifier. And now you're calculating 4 quantities, and here you have a power supply. Okay. Now let us do analysis. So you read the steps. Number 1 step is what? Number 1 step is you have to perform what? DC analysis. DC analysis. This will be open. So you remove this one. Remove this one. And now this is your as usual circuit. Whatever value will be given, RC, IE, beta value will be given. You have to find the value of how much current is flowing here. IB is coming here, capital IB coming here, capital IC coming here, and here IE current coming. So you do DC analysis, and you have to find the IE, and that is same. That is no need for discussion, okay? Because we already done so many problems. So first step is DC analysis, and find DC analysis means find IE, capital IE. That is done. That will do whenever value will be given, we'll do that one solve. And now if I want to do AC analysis, I want to find the 4 quantities. Now second is AC analysis. What are the first part of AC analysis? Tell me. Capacitor will be short circuited. So capacitor will be short circuited and you have direct V input here, and now you are measuring V output here. Capacitor will be short circuited right there. Capacitor will be short circuited and power supply will be turned off. So here is a one power supply only turned off. That means make it ground. This is my circuit. Now I will draw now the next step is simplified circuit. So I have a transistor. Okay, here I have current, IB current is coming. Okay, now what I will do, this is grounded, this resistance is between base and ground, so I will put it here. This is base and ground, I will put it here. This is my RB and this is your ground. Okay, I will replace this one. And what is coming here?
Excuse me, sir.
Tell me.
सर कैपेसिटर सर पहले वाले केस में भी सर ओपन लिया था उसको, और सर अभी भी सर उसको शॉर्ट सर्किट कर दिया।
अभी शॉर्ट सर्किट कर दिया है।
तो उसका काम क्या है कैपेसिटर का सर लगाने का सर इसमें?
भी यहाँ से अगर कैपेसिटर लगाओगे तभी तो ये वोल्टेज यहाँ से करंट पास करेगा, अदरवाइज तो इसी काम करेगा ही नहीं ना। और ओपन कर दिया तो ये पहले हमने ओपन कर दिया तो ये डीसी यहाँ जाएगा नहीं, डीसी सीधे यहीं आ जाएगा करंट। यहाँ ओपन हो गया तो आपका अगर ओपन है तो ये लग नहीं रहा है उसके ऊपर, ठीक है।
अच्छा अच्छा। हाँ।
और जब एसी एनालिसिस कर रहे हैं तो ये डीसी काम हो गया, अब ये शॉर्ट हो जाएगा तो अब करंट यहाँ से ये अप्लाई हो जाएगा इधर।
अच्छा, ओके सर।
ओके, नाउ नेक्स्ट इज दिस इज RC, this is the collector, this is a ground, so this is a collector and this is ground. बस इतना ही ड्रॉ करना, सब बार बार इसी को ड्रॉ करना है। this is RC, okay, this is your simplified circuit. Here you are applying V input, okay, and here you are measuring V output. This we are just turning, that's it. This is simplified circuit. Now third is replaced by RE model. Now this I will replace by RE model. So this is your V input. This is your RB. Now RE model says this replace this transistor. So I will put a resistance. What is the value of resistance? Tell me. What is the value of resistor? This resistor. What is the value?
RE, sir.
Beta RE.
Yeah, beta RE, right.
Beta RE. IB is coming here. Here is coming input current. Here is coming input current. IB will come here. IB is coming in the beta RE. This we are replacing this one. IB is coming in the base. Here one resistor is there, so is the input current is coming here. Okay, that corrected here. So this is the input current coming here. Okay, and now what is the other thing? This part we will replace by a current source, and this will be grounded, and parallel will be a resistance R0, and this resistance is already there. I0 was coming from here, I0 was coming from there. This is your I0 in a circuit RC, and now there is this resistance is there. You just keep it like this as it is, RC. Now that's it. This become your simplified circuit. Now you have to solve this circuit. Now you are measuring V output here. You're applying V input here. You're measuring V output here. And now you have to do the analysis here. Now it is very simple. Say first I want to find the input resistance. Input resistance. So input resistance is basically what? Input resistance is Ri equal to V input upon I input. Okay. So this I input going in both the registers. Okay. So tell me how to find the VI input. Tell me how to find the I input. This current is IB. This current is IB. This current is I input. How to find I input? Tell me. So कौन बताएगा how to find I input? So I input is basically what? I input is basically total voltage divided by total resistance. What is the total resistance here? RB parallel to beta RE. Yes or no? Can I write like this? I. This is the voltage. Okay, and this current is going here and here. So can I write like this? I input equal to VI upon RB beta RE.
Yes, sir.
Okay. And one more thing is, ठीक है.
Sir,
Tell me.
I have a question. Sir, in DC biasing cases, when we solve the KVL system, at that time we just consider the RB and RE basically in series combination. But here we are taking it there in parallel combination. What is the law?
Where is RE? Where is RE?
RE means beta R. That is the resistance across the transistor.
Yes.
Right. So we took in that DC biasing cases.
See, this is the resistor. Okay, this is connected from here to ground, here to ground. Okay, and now RB is coming here. This is RB, and now I'm making this ground. So base with the base and ground is here. So this become parallel. Okay, this become parallel. With
Okay,
this DC analysis, we never consider this part, na? We only take RB. We are not taking beta RE. Yeah.
We took beta BE. We took beta BE. VBE.
VB voltage drop, na?
Exactly.
Okay,
Got
so
it.
that is different thing here. Okay. Here
Okay.
So now this is RIA. So put the value of now RI equal to what will happen? BI upon BI divided by RB parallel beta RE. So my number one quantity is RI. So what is the value of RI? RB parallel beta RE. That's it. You can directly see, na, if I want the input resistance here, in order to calculate input resistance, what we have to do? We have to turn off all the sources, make it open here. This will be open, and here this resistance between these two terminals is what? Parallel combination of this one. That is simple. Directly you can write. No need to do all this one. RI is this simply RB. How much resistance are there? You just sum it. That is an input resistance. Okay. Similarly, second thing. What is the output resistance? This is input resistance. Okay, now second is output resistance. What is output resistance? R0. Tell me. In order to solve input resistance, output resistance, you even don't need to do DC analysis also. Directly, if you draw the circuit, you can directly tell the values. Okay, what is R input and R output? What is R output? So if I want to measure R output here, I have to turn off all the sources. So when I turn off the sources, current source will be open. So my R0 will be simply R0 parallel to RC. Okay. I0 is coming here. I0 was coming here, and here was beta IB. Okay. That way also you can solve. That way also, but directly you can find out what is the parallel. You can write a parallel. No need to remember the formula also. Just put the parallel combination. This is R0 RC. Now, if I say if R0 is greater than RC, then R output will be equal to, tell me, what is the value of R output? If R0 is greater than RC, then what is the value of R0? Karishma? This is the combination of R0 RC. So 1 upon R0 is equal to 1 upon R0 plus 1 by RC. If R0 is greater than RC, then what is the value of R0? इन पैरेलल सर्किट कौन सा रजिस्टर डोमिनेट करता है, छोटा कि बड़ा वाला? इन पैरेलल कॉम्बिनेशन which register dominates, small one or bigger one? Leo?
Smaller one.
Smaller one. So suppose this is infinite. Suppose this is infinite.
It will be negligible.
So this will be 0. This is negligible. So R0 will be what? RC. So now.
Yes, sir.
So why you are not replying this small things? Okay. So R0 will be RC. Deepak, is that clear?
Yes, sir.
So whenever if R0 is if R0 is open, is infinite, that means it's open. There's no resistance, and now this resistance is here open terminal, output resistance is open terminal, output terminal resistance. Output terminal is only RC. So this will be given the question. Either you find this way, if it is very high compared to this one, you can neglect this one and you can directly out to RC. Okay. So 4 quantity we have to calculate for every circuit, and now the next quantity will be what? Next quantity will be your gain, voltage gain. Voltage gain. Voltage gain is AV, that is equal to V0 upon V input. Okay, put it current back here. This current coming here, beta IB. This current is beta AB. This current is I0, as we defined in the earlier circuit. This is the input. Now first we have to calculate the V0, and then we have to find V0. We have to take a ratio that will give you a gain. Okay, once you know the formula, same formula will keep on coming again and again with a little bit variation for different circuits. We'll see that one now. Now I want to get the say V0. Okay. So, and V input. So what is V input? First tell me, can I write V input? V input is this one. This is equal to what? This voltage plus this voltage. Now this voltage is your IB beta RE. This is my, can I write like this? V input, can I define V input like this? And now if I find V0, RI is different. RI is the total current. Okay, if I want RI, I want VIII. But if I want simply VI, that will be this. Now this current also we can find. This is total current. This much is going here. How much will go here? That also we can find. So either this voltage or this voltage. So I know this current directly. So I can directly write IB beta RE. So IB beta RE is my V input. Now tell me what is my V0? What is V0? I am measuring V0 like this. Can I write V0 equals to I0 RC? Can I write like this?
Yes, sir.
Okay, you can directly write. And now can you write I0 in terms of beta IB? Can you write beta IB? So this is total current. This is a total current. This is a total current. Okay. Tell me how to write I0 in terms of beta, because here is IB. So I want to write this also in terms of IB. बताओ भी कैसे लिखते हैं? If total current is beta IB and this, if I want a current in this branch, how to find out current? How to find out I0? I0 is equal to total current. If I want current in this branch, I will take resistance of this one plus total resistance R0 plus RC. Can I write like this? I0 equal to like this? Tell me.
Yes, sir. Yes, sir.
This is a total current. I want current in this branch. So I'll take resistance of opposite branch and sum of resistance. So I have now the value of I0 also. So my V0 will be what? Now my V0 will be, what I'm putting minus, because I am measuring voltage like this, but current is going like this. So here voltage drop is like this, but I'm measuring like this. So this will be my minus I0 RC. Gain, in common ammeter gain always is negative of the input. That is, there's a 180-degree phase change in the common ammeter configuration. So now put the value here, beta IB R0 plus RC. Find the ratio. voltage gain AV. So AV will be what? AV will be V naught by V input, that is B minus beta IB R naught R naught. Now gain will be always positive. Gain you take to define as a positive quantity. Okay, it's not negative quantity. Voltage like this, and now this is your IB beta RE. So IB cancel. Okay. So now what is the formula for this one? Beta cancel. Beta cancel. So now my voltage gain will be what? My voltage gain, I'm rubbing this one. My voltage gain is equal to R naught RE R naught RC. Just give me 1 minute. I'm doing a mistake. RC was there, na? This RC also there, na? So my V naught is I naught, RC also there. RC also there. Okay. R naught RC. Is that correct? Now I want to simplify this is little bit more. Or V naught you can write in another way also. You know this total current is coming from out of these two. So I can take combination of this one. Okay. I'm writing one. This is the formula. I will solve this one. I'm rubbing this one. Can I rub this one?
Yes, sir.
So now if I say my R naught is greater than RC, then in this term I can neglect RC because R naught is very high. So this will be R naught RC RE. This gain AV will be R naught plus RC is R naught. R naught also cancelled. So my gain become RC by RE. Is there a minus sign? Oh, they are putting minus. No, minus sign is not. Just give me. They're putting minus sign also. Okay. So V naught they are taking with a minus sign. Generally we don't. Okay. So if minus is there, put minus also here. So this will be your gain will be now minus RC by RE. I'm writing here. So 4 formula you have. So V naught become, if you take magnitude of gain, then you can remove the sign. Okay. You can send. So this, so you have gain AV, that is minus RC by RE, voltage gain. Now you can, if you don't understand this way, you can do another way. Say, how can you do it? You know the total current is beta AB, and you can take the equivalent resistance of R naught RC. So I can say directly say my this V naught is equal to, I can say my V naught is equal to minus total current. Total current is beta IB into RC parallel to R naught. Like that also you can write beta IB RC parallel to R naught. And V input you already know. So again you can find the gain. Gain will be V naught upon V input by V input. So V input is a minus beta IB RC parallel to R naught. Total resistance, total current. Okay, this will be your equivalent resistance. I'm replacing by this one, and this current is going here. This current going like this. So this is the output, and now divided by input. Input is what? Input is IB into beta RE. Beta cancel. Beta cancel. IB cancel. So again you get the same formula, minus RC parallel to R naught divided by RE. So better to remember this formula for gain. And if R now if R naught is greater than RC, then you can neglect the R naught, and your gain will be simply minus RC by RE. RE, how to find out? RE will be calculated from the DC analysis, RC will be given in the question. Just take the ratio, that is your gain. Is that clear to everyone? Deepak, Karishma,
Yes, sir, got it.
Leo?
Yes, sir.
So this is the formula. Okay. Now you want to find the last quantity. So in exam only it will ask one quantity, only one quantity. They'll ask again current gain, voltage gain. 4 will not ask, but I am telling you everything. Anything can be asked. Okay. Now you want to find the current gain. Now you want to find the current gain. Problems we do later. Okay. First we'll try to find the formulas. Now the fourth quantity is current gain. Current gain is AC, that is I naught upon I input. Okay. So similarly, now you have total current I input and current going in this beta RE I know is IB. So from by calculation, I can calculate what is the value of I input. So if I want to find IB, current in beta RE, total current is I like total current into, if I want current in this branch, I have the resistance of this one, RB, and sum of resistance RB plus beta RE. So this is my IB, so I can find now I input. So I input will be IB RB plus beta RE upon RB. This is my I input. And I naught, just now I written. What is I naught? Total current, beta IB, R naught plus RC, R naught plus RC. Now gain will become AC will become beta IB into R naught plus RC IB RB plus beta RE, and it will go to the RB. Now IB cancels. Okay. Now in this question also, if R naught is greater than RC and RB is also greater than beta RE, beta RE generally comes in the ohms because the input resistance of diode is very less. Means ohms. And if RB is kilo ohms, very high, then your input resistance is what? Input resistance is RI, simply beta RE parallel to RB. So if RB is very high, your internal resistance will be simply beta RE. You can open this one. So similarly here, now this is the formula, put the values. Now neglect RC compared to R naught, neglect beta RE compared to RB, and tell me what is coming, answer is coming. What is the value of answer? What is the current gain in common ammeter configuration? So if I take now gain, I'm rubbing this one. So my current gain AC now becomes here R naught will be neglected. So RC will be neglected. R naught will be cancelled. Similarly, if I had beta, this is R naught, RB. If this is
Sir,
very
AC
high,
is equals to beta RI.
yes, हाँ बीटा ओनली बीटा आएगा. बीटा आता है करंट, हमारा गेन कितना होता है करंट गेन? R naught, and this is RB. RB cancel, so is coming beta. So AC is coming beta, और कॉमन एमीटर में करंट गेन बीटा होता है. तो ऑलमोस्ट अगर if you use this formula or you use this formula direct beta, they will be almost same. That's what I want to say. Okay, if you neglect this one very high, then that you can directly say my gain should be around somewhere close to beta. Exact value will become this formula, and roughly value will come by whatever beta will be given. Both should be same. Now, once you understand this one, so this was fixed bias circuit. Okay. Now there will be another different biasing. For those biasing also we have to do equivalent circuit and we have to find the values. Okay. Now let us do for different type of biasing. I'm rubbing this one. I will use a different kind of biasing. So generally questions comes from the voltage divider bias, but we'll do 3 type of biasing. Then next is common ammeter. Common ammeter. Okay. Bias configuration. Common ammeter bias configuration. Ammeter bias configuration. Configuration. Now you can directly write, nothing will much change, same, everything will be same. If you understand this one, remaining you can do very easily. Now circuit will change little bit. Now you have, say, this one. You have a RC. You have a plus VCC. Okay. And this VCC coming RB here. And now only the change is there. Here you have one more resistance RE. Nothing has changed. Now earlier it was directly grounded. Now this resistance, now you have to find the equivalent resistance of this one. Of course, there is a capacitor. Here is also capacitor. This is a V input. This is a V output. This is a C1 bypass capacitor, C1, C2. Now what I supposed to do? AC analysis, DC part will already know. We not do here. When we solve the problems, that will we see. Now I will do directly AC analysis, means first I will do the equivalent circuit. On the equivalent circuit, I need to calculate the 4 quantities. So for equivalent AC analysis, this is your, I'm doing AC analysis. Now you can do it yourself. AC analysis. This is removed. Okay. Now put the equivalent circuit. This will be replaced by resistor. So what is the equivalent circuit? Current is coming here, I naught. Okay. And here current was I input when VI was there. Okay. And here current is IB. That you have to remember. So now again, this will be grounded. Power supply will be grounded. This will be short circuited. So now I can directly write V input will be again, this will be RB. This is my V input. I input current is coming from here. Now base is replaced by what? Base is replaced by, tell me what? Here you have a RE. Here you have resistance RE. Now it's not directly connected. His RE is between RE, and this part will be replaced by, say, beta RE. Beta RE. Okay. And here output is current is coming what? Output current is coming triangle. This is coming like this. Or you can put this is in between, so it will look good. Remaining circuit is same. Only here RE is there. Earlier it was grounded, now it's not directly grounded, it is resistance here, this resistance, okay? And this is your beta IB. And here you can put R0 and you can put a RC. Now similarly, here current is flowing IE, but I want to write current IB. So again, I have to multiply this by also beta. If I say current is here IB, then I have to replace this by beta RE because the actual current is RE. So this circuit is same, parallel like this. You have one more resistance here. This is the thing. And now you have to find all the 4 quantities again, like previous thing. Nothing will change now much. Now tell me what is the output resistance, this input resistance. You can do it yourself now. First quantity, input resistance. Tell me what is the input resistance. So when I'm calculating input resistance here, terminal, all sources should be open, like at R Thevenin. So when I'm calculating this one, this current is not there. Say assume this current is there, nothing is there. I'm only find this R input. So R input will be what? RB parallel to what is the resistance here? This resistance, हाँ? अरे भाई ये एक रेजिस्टेंस है, एक ये रेजिस्टेंस नहीं है क्या? पूरा कितना रेजिस्टेंस है ये?
सर बीटा RE plus RE.
हाँ, so I will take this resistance as a beta RE plus RE. Now if you want, you can write this as a ZB. You can write this combination as a ZB. So this is beta RE plus RE. So my now R input formula will become what? This will be RB parallel to ZB. That's it. Now if it is RB is greater than ZB, it will be only ZB. If ZB is greater than RB, it will be only RB. That is the input resistance. Now put it back here. What is the output resistance? Deepak, what is the output resistance?
सर पैरेलल हो जाएगा सर ये
बस दोनों दो ही तो है यहाँ पर, वो सेम ही होगा. R naught parallel to RC. That's it. कुछ चेंज नहीं है, पहले ऐसे आएगा. This is open. You're measuring resistance, Thevenin equivalent. So all sources should be deactivated. This will be open from here. So you have only two resistance, R naught RC. That's it. R naught RC. वोल्टेज गेन भी सेम ही है. अब आप निकालेंगे वोल्टेज ना, वोल्टेज गेन. व्हाट इज वोल्टेज गेन? Voltage gain AV. What is V input? Tell me what is V input. Tell me. ये वोल्टेज कितना है? Very good. IB into beta into RE plus RE. Generally RE is very less compared to this RE, so you can neglect this RE also. Okay. And V output is same what we done earlier. What is V output? I naught is coming from here. The total current is beta IB. So I minus beta IB total current into RC parallel to R naught. That's it. V naught. Total current, total resistance. तो गेन क्या हो जाएगा? गेन सिंपल हो जाएगा. गेन फॉर्मूला इज माइनस beta IB RC parallel R naught, and here is your beta IB RE plus RE. This is cancelled out. So your voltage gain is again same, RC parallel to R naught or RE parallel to plus RE. So earlier it was only RE, now it's plus RE is there. So RE plus RE, top thing is same. So you don't have problem remembering formulas also. Directly you can remember the formula. And now if R naught is greater than RC and RE is also greater than RE, then the V naught formula will simply become RC by RE. That's it. फॉर्मूला थोड़ा दिमाग में रखना है। डोंट, अगर पूरा याद ही तो भी हल्का सा ध्यान रखना है, ताकि उस समय आराम से आप निकाल लो फटाफट एग्जाम में। Now next is current gain. Current gain, this the derivation will be same. What is current gain? Current gain. Let us try it. I am rubbing this one. So current gain is AC. Okay. Input current I. What is input current I? Tell me again. What is the input current? Can I write input current like this? IB. First you write IB. What is IB? Total current is I input into, if I want current in this branch and the resistance of this one, RB, and then beta RE plus RE. So here I can find I input is equal to IB beta RE plus RE upon RB. What is I output? I output is same now. I output is same. Total current beta IB into R naught plus RC. खुद निकाल के देखो सही आ रहा है कि नहीं आ रहा है। अब रेशियो निकाल लो।
और ये हम आईपी कैसे लिख रहे हैं सर?
ये कौन, ये IB।
यस
अगर मुझे करंट इस ब्रांच में करंट चाहिए, टोटल करंट आई है, तो मैं कैसे लिखता हूँ? टोटल करंट, ठीक है। ये पैरेलल रेजिस्टेंस है, सामने वाला रेजिस्टेंस RB, देन सम ऑफ रेजिस्टेंस। सम ऑफ रेजिस्टेंस क्या होता है? सम ऑफ रेजिस्टेंस नहीं, सम ऑफ रेजिस्टेंस, to write sum of resistance. Sum of resistance is what? Sum of resistance is RB plus beta RE plus RE. That is the thing. It's not correct. This is the correct. So now I input will be IB RB plus beta RE plus RE upon RB. And beta, and this I naught is clear. अभी क्लियर है?
यस सर।
Now just find the ratio current gain. So current gain is the I naught upon I input, that will be beta IB R naught plus RC, and here IB RB plus beta RE plus RE into RB. Okay, this is the actual formula. And again, if you take if you say R naught is greater than RC and RB is, this is basically ZB. Okay, beta RE plus RB, I have written ZB na, so you can write this is equal to R naught RB R naught RC. So this is RB plus ZB. Now, if R naught is greater than RC and RB is greater than ZB, then the simple formula will become again beta, or exact will be by using this formula. Now let us do the next important biasing, voltage division. बाकी तो सब एक जैसा ही है, थोड़ा थोड़ा चेंज होगा बस. The next is your voltage divider bias. Voltage divider bias. Okay, so here we have two circuits. So we'll do number one circuit is when you have plus VCC. This is a voltage divider circuit. You have a resistance RE. This is R1, this is R2. Here is capacitor. Here is V input. I input is coming from V input. And here you have a, I'm measuring V naught here, RC, and current is coming here. I am telling this is I naught. And here is also capacitor. Now, one time I put capacitor here. This is C1, this is C2, and this is CE. One time I put a capacitor, one time I will not put the capacitor. So there are two circuits. So this is with feedback capacitor. This is number one circuit is with feedback capacitor CE, with the feedback capacitor CE, or bypass. This is also called bypass. Okay, bypass or with bypass. You are at bypass capacitor with bypass capacitor CE present. This capacitor is present with bypass capacitor CE is present. Number one thing. Another time it will not be present. Now redraw the circuit. Tell me what is circuit now. So for AC analysis, number one thing, this will be short, this will be short. अगर ये भी short है तब क्या हो जाएगा? If this capacitor is short, then what will happen? Tell me. If this capacitor is short, then
सर RE से सर करंट नहीं जाएगा ना फिर?
RE बैठ जाएगा. If this capacitor is short, this is present, okay, with bypass capacitor CE present, this RE will be short circuited. So इसको RE का हट जाएगा. This will be directly grounded. That is the advantage. If this is if the C is there, so my equivalent circuit will be now what? My equivalent circuit will be now, this will be short circuited. Okay, I'm putting directly circuit. This will be short. So this is my V input. I input current is coming. This will be grounded. So only R1 is there, R2 is there. Base, this is the base capacitor. R1 is there. R2 is there. R2 is also grounded. If this is grounded, this is already grounded. So base and grounded, base and grounded. Okay, and this will be represented by what? This will be represented by, say, beta RE. This is represented by, here resistance is directly become ground. This is your beta RE, and here you have source is coming, beta IB. Again, the output is same, RC and R0, R0 parallel to RC, and you're taking V0 again here. Remaining circuit is same, only we have to now see what happens to RC. So let us solve now. This is grounded. This is also grounded, and this is also grounded. Now, if you want, you can separate it out because both are grounded, so you can directly draw it simple circuit what we done earlier. So now what I can do, I'll do, this is V input, R1, and now R1 and R2 I am writing as a R dash combined, and now this is your directly beta RE, and here you are directly source beta IB, and here you have a same circuit R0 RC. Here I0 is coming and here V0 is coming. Again, you want input resistance Ri, that will be R dash parallel to beta Re. R dash is R1 parallel to R2. R0 formula will not change. R0 will be same like what? R0 parallel to RC. Voltage gain AV. What is V input? V input is again, here is IB. IB into beta RE. V naught. V naught is beta I minus beta IB R naught parallel to RC, R naught parallel to RC, R naught parallel to RC. So gain formula become gain again same minus beta IB R naught parallel to RC. Okay, divide by IB beta IB RE cancel out. So gain formula is not changing with this R dash. Okay, so input resistance is not coming. So minus R naught RC upon RE. R naught RC. Voltage gain formula is very important. If RE is there, this will be just R plus RE. This will be always same. This will be RE plus RE. That's it. Now current gain. Can you calculate current gain yourself? Current gain is still the same way you can find out. Find out current gain. And then we'll do last circuit with bypass capacitor not present. Now this very interesting questions comes in exam. एग्जाम क्वेश्चंस कल करेंगे, बट आपको खाली फार्मूला याद होने चाहिए बस. सर्किट देख के you can should able to draw the formulas. Okay, tomorrow we'll do problems. So now let me write the current gain. करंट गेन क्या हो जाएगा? फर्स्ट टेल मी व्हाट इज आई बी। आई बी कितना है बताओ? व्हाट इज आई इन टर्म्स ऑफ आई इनपुट? व्हाट इज आई इनपुट? कौन बताएगा? आई इनपुट कितना है?
सर आई अपॉन
हाँ
सर आर डैश आई अपॉन
हाँ,
आर डैश अपॉन आर डैश प्लस बीटा आर ई।
गलत कर रहे हो। आर डैश प्लस बीटा आर ई अपॉन आर डैश टोटल करंट। If you want, first you have to write IB na. IB is total current. IE into beta R, opposite resistance R dash upon R dash plus beta RE. So if you want IE, that will be IB into this one divided by this one. अब 3 बार कर चुका हूँ, अभी भी नहीं बता पा रहे हो कैसे करेंगे?
सर आई बी का बता रहा था सर मैं।
हाँ IB का, तो I ही निकालना आपको तो।
हाँ सर मैं आई बी का बता रहा
हाँ
था।
ठीक है। अब बताओ आई आउटपुट का फॉर्मूला क्या है? आई आउटपुट का फॉर्मूला क्या है? करिश्मा, अपर्णा, व्हाट इज द फॉर्मूला फॉर आई नॉट?
सर बीटा आई बी
हाँ,
आर नॉट
आर नॉट
अपॉन आर नॉट प्लस आर सी।
हाँ सेम ही है। ओके, एंड द करंट गेन विल बिकम नाउ व्हाट? बीटा आई बी आर नॉट प्लस आर सी आई बी बीटा आर ई अपॉन आर डैश। ओके, so AC formula will become R naught R dash plus beta RE R naught plus RC. Okay, and again you have to check if R dash is greater than beta RE and R naught is greater than RC, then your AC will come again beta. जो भी दे रखा क्वेश्चन में, और ये हो सकता है कि ये देखा इट इज गिवन दिस वन बट दिस इज नॉट गिवन, then you have to do little bit more. So this is the actual formula and you have to change little bit variation here. Okay, now the last, when AC bypass circuit is not present, that time what is the formula? Again voltage divided bias, voltage divider bias, second case with bypass capacitor CE not present. So you have circuit R1, R2, RE, R0, V input, C1, V output, C2. Now this is not present. Here current is not here, current is here, I0, current is here, I input. Draw the equivalent circuit and calculate all the 4 quantities. Almost same quantities will come. There will be nothing change. Little bit change will be there. So RE model equivalent circuit. This will be grounded. So again, R1 will come here. Okay. Again, this is beta RE. Here you have a RE. Here current source is coming. Here you have a R naught. You have RC. And here's a V naught. And current is beta IB. I naught is coming from here. I input is coming here. Current in the base going IB. This will be replaced also with beta because you're saying current is IB here.
Sir, I have a question.
Hmm.
In the output circuit, we took obviously R naught and RC in parallel.
Hmm.
And this is a current source. So
Hmm.
is there the voltage drop across RC or the voltage drop across R naught are same since
Same,
they are
yes,
parallel?
same. If you
Okay, okay.
if you can find the current, this current, if you anything total current is this one, so you can find
Yeah.
what is this current, total current this one, you can find what is the current this one. Here current
Okay,
is there.
in that case, we if we calculate the voltage drop across RC, we also find the output voltage also.
Yes. I not RC.
Okay.
V naught
I
is
not.
also I not RC.
Okay. Thank you, sir.
That is same thing. Directly you can find, and you can find ratio. Where if you don't want to use formula, directly you find this one. If you know this current, you can directly find the I naught value is IC. If you know beta IB, directly you find this one and find directly this one with formula. If values are given, just we are not doing formulas, na. If values are given directly, you can find. Yes or no?
Okay, sir. Got it. Thank you, sir.
So now this is input resistance, same thing. Input resistance, I am putting R dash equal to R1 parallel to R2. So my input resistance Ri again, when I'm measuring open terminal resistance, make all sources is open, make all sources open is open. So R1 this parallel to this whole parallel. So this is R dash parallel to beta Re plus Re. And shall I write this ZB? This is a ZB. So this is beta Re plus Re. I am writing ZB. So Ri will be again R dash parallel to ZB. Nothing change here. R naught में तो कुछ change होगा ही नहीं. R naught is remains the same. R naught remains the same. R naught parallel to RC. Voltage gain will also remains, only Re will come. Now find the voltage gain and current gain also. Now what is voltage gain? So voltage gain third AV V input is IB into beta RE plus RE is IB going here. This is the V input. V output is same minus I naught RC or total current. This is minus total current beta IB combination of parallel R naught RC. So gain will become AV minus R naught parallel to RC. Okay, this will cancel out, and RE plus RE. Now RE present because capacitor was not there. Now calculate current gain. So problems tomorrow we'll do. Okay. Now current gain you can find out same thing is there. एक ही चीज को बार बार कर रहे हैं पर तुम लोग कॉपी में बाद में करोगे नहीं, इसलिए मुझे करना पड़ता है बार बार. So now input current will be IB into R dash okay, these are parallel na. So I will be R dash plus ZB, R dash plus ZB upon ZB. Is that the correct formula? Tell me. ये सही है क्या फॉर्मूला, बताओ.
सर आर डैश आएगा ना.
हाँ आर
नीचे.
डैश है ना, ये आर डैश है ना. आर डैश नीचे क्यों आएगा भाई? अगर मुझे आई बी लिखना है मैं आई बी कैसे लिखूंगा? आई बी कैसे लिखता है? टोटल करंट आई इनपुट इनटू इसके सामने वाला रेजिस्टेंस, इनका इक्विवेलेंट आर डैश. हाँ सॉरी, आर डैश एंड देन आर डैश प्लस जेड बी. तो आर डैश आएगा करेक्ट. So I input you know. Now what is I output? What is I output? Total current beta IB. यहाँ माइनस नहीं आएगा क्योंकि करंट निकाल रहे हैं. R naught plus RC. Now find the current gain. Now I naught will be what? I naught upon I input current gain will be beta IB R naught plus RC IB R dash plus ZB into R dash. So again, if you solve this one, if R naught is greater than RC and R dash is greater than ZB, then AC will be your again beta. But this is the actual formula. ये directly भी आपको remember करने की जरूरत भी नहीं, you can directly write it. Okay. So I'll stop here. Thank you.
Thank you, sir.
थैंक यू सर.
हो गया, क्लास खत्म हो गया. 1 minute, baby. Just 1 minute. हाँ, 1 मिनट खत्म हो गया बस. हाँ, हेडफोन निकाल. वो 7:30 है.